Kia ora, and welcome back to this second video on the introduction to the normal distribution. So as we said, we got a bell shape with the mean in the middle, and that's represented by the Greek letter mu. We've got a way of talking about the spread, and that is called the standard deviation. Again, the standard deviation is a measure of spread, or how far apart things are. We want to use those standard deviation measurements to describe how likely or how probable it is to be a certain distance away from the mean. So as we said in our last video, you've got a 34.1% chance of being within one standard deviation above the mean. And the notation there, mu plus 1 sigma, or that is one standard deviation above the mean. So from the first standard deviation to the second, we've got 13.6% of the values are likely to be between the first and the second standard deviation. And between the second mean plus 2 sigma up to the third, we've only got 2.15% of the data between that second and third standard deviation. Again, if you haven't already done so, please put this in your notes. It is going to be good to have this committed to memory. Next. Okay, later we're going to explore some more detailed methods for finding the mean and the standard deviation for normal distributions. For now, we need to know these simple rules of thumb. That 68% of the data lies within one standard deviation of the mean. And the way we got that, we have 34% below one standard deviation, or rather from the mean to one standard deviation below the mean, and from the mean up to one standard deviation above the mean is another 34%, 34 plus 34. That's where we got the 68%. We also need to know that 95% of the data lies within two standard deviations, and about 99% of all of our data lies within three standard deviations of the mean when the data is said to be normally distributed. Okay, so 99% of the data lies within three standard deviations either side of the mean. That means if there's three standard deviations below the mean and three standard deviations above the mean, we can say that most of the data lies within 6 standard deviations, or 6 times sigma. And we can use this to estimate the range of a sample. The range of the data is going to go from 3 standard deviations below the mean to 3 standard deviations above. In other words, the range of the data is 6 sigma. Okay, now the values for mean and standard deviation can vary, and that affects the spread and the height of the curve. The diagram below shows us two normal distributions with the same mean but different standard deviations. So the mean is here in the middle, and remember that this is simply a ruler, a scale, a number line. Now the blue curve has a larger standard deviation. Reason why: the blue curve is wider, so it's more spread out, and as we said, standard deviation is a measure of spread. Where the red one, since it's narrower, it's less spread out, so we can say the red curve has a smaller standard deviation, but they both have the same mean, and as we said, that mean is right in the middle. Now we're going to talk about using the standard deviation. We just come back to summarizing what we talked about before. Make sure that is in your notes. Let's look at an example. If a normal distribution has a mean, which is in the middle, of 270 and a standard deviation of 16, what range of values will contain data 2 standard deviations above and below the mean? Well, if one standard deviation is 16, then 2 standard deviations would be 32, 16 times 2. So 270 minus 32 would bring us to 238. Above that, it'd be 270 plus 32, or 302. All right? We'll be back with one more video. We'll look at these other examples. Be right back with a video 3.